Two archaeologists have found the fossilized plants and wanted to know its age. Each one of them predicted a number, but they wanted to know the truth, so they turned to a scientist whose answer was carbon-14 dating. But the question is, why exactly carbon-14? Carbon-14 was made in the upper atmosphere, whose gas is mainly constituted by oxygen and nitrogen. And what you should know about nitrogen is that because of cosmic rays, it becomes carbon-14. And carbon-14, like all the other type of carbon, oxidizes on contact with oxygen. But the carbon-14 aren't the only ones in the upper atmosphere. There is also the carbon-12, who, in the other hand, is much more abundant. Now, the carbon dioxide is essential here in Earth because plants breathe it and the animals eat plants and we eat animals and plants. And those molecules, carbon-14 and carbon-12, that make up the carbon dioxide get in everything organic. While the organism is alive, the amount of both carbon-14 and carbon-12 is constant thanks to exchanges with atmosphere. But when it dies, the amount of carbon-12 doesn't change, unlike carbon-14, who gradually begins to decay. And American chemists Willard Levy have figured out that it actually decays at a predictable rate. That means that it's radioactive. And like all the radioactive particles, carbon-14 has what's called a half-life, and its half-life is 5,713 years. That means that after 5,713 years, the amount of carbon-14 that you will find in a fossilized organism will be half of what it was the last time this organism took a breath of life. And after two half-lives, it will be the quarter of what it originally was, and so on, until there is none left. And by this way, we can know the age of all the organic sample and they're 50,000 years old, because then the quantity of carbon-14 will be too small. Now let's apply this on our fossil.
First, we must calculate the number of carbon-14 particles that the plant contained before dying, and for that, we will calculate the number of carbon-12 particles. And since in 1000 billion atoms of carbon-12, we have one atom of carbon-14, then we will divide the number of carbon-12 per 1000 billion. Second, we will calculate the number of carbon-14 that we have right now, and based on that, we will find the percentage. And for our fossil, it's 25%, and based on our curve, the fossil is 11,416 years old.
It's pretty old. And future archaeologists will have a lot of trouble using this method because we really did mess up with atmosphere. Sorry.